In this course section, we are now going to dive into a very popular third-party React library, the Redux library. And we're going to understand what exactly Redux is, why it is so important for the React ecosystem, and how we do use it in React applications. Specifically, we're going to start with the very basics, of course. What is Redux and why would we use it? Then we're going to explore how we use it. So we're going to dive into some Redux basics. And of course, we're also going to learn how we use it in our React project. By then, we'll also know what exactly it does, no worries. And we're going to explore a related library or tool called Redux Toolkit, which simplifies working with Redux, as you will see. Plenty of content to cover. This is an important library, so let's not waste any time and let's dive right in. So what is Redux? Redux is a state management system for cross-component or app-wide state. So it helps us manage state, data that changes and affects our application and what we display on the screen. It helps us manage such data across multiple components or even the complete app. Now, just to make sure that we're all on the same page, we did, of course, use state a lot in this course already with the use state hook or also with use reducer. And indeed, those hooks exist to allow us to manage data that typically changes, for example, when the user clicks a button, and where changes to that data then typically lead to the UI being updated. We use React's state management hooks like useState so that we can tell React that some data changed and so that it then updates the UI for us. That's what we did throughout this course. And that is what state is all about. But we can split the definition of state into three main kinds of state. We have local state, and we also have cross-component and app-wide state. Now, these are not hard definitions. These are just definitions which you will see a lot, or these are separations of state which you see a lot, and therefore I also like to use them. Now, what is a local state? Local state is state, so data which changes and affects the UI, which belongs to a single component. Now, for example, if we listen to a user input and we use state to store that input with every keystroke in a state variable. Or we have a button that toggles some detail field. So if we click that button, we show the details. If we click it again, we hide them. That would be local state. And typically we manage such local state inside of a component with use state, or if it's more complex, maybe with use reducer. Now, we also often have state that affects not just one component, but multiple components. That would be cross-component state. For example, if we have a button that opens or closes a modal overlay, such a modal component might affect multiple components, and the trigger for opening the modal is per definition not inside of the modal. On the other hand, the modal might be closed by clicking a button which is inside of that modal. So then we have multiple components working together to display and hide a modal. And we can also implement that with use state or use reducer. We then just need to pass props around. So we need to build those prop chains or do this prop drilling, as it's also called, where we pass props across multiple components, where we also might pass functions as props across multiple components so that these different components can work together and manage state together. And that's not bad or anything like that, it's just a little bit more complex than local state. And sometimes we also have state that does not just affect multiple components, but basically all components of an application. Now, when that happens, we could call this app-wide state. And an example here would be user authentication. If I log in, we might need to change the navigation bar because we now show new options. And we also certainly affect a lot of other components which now show more or less data. So that would be an example for app-wide state. And we can also manage this with use state, use reducer, and then by passing state values and updating functions around through props. That's what we did throughout this course, and that of course works. Now for cross-component and app-wide state, passing around data and updating function through props can become cumbersome though. And that's why we did learn about React Context before in the course. React Context is a built-in feature in React that makes managing cross-component or application-wide state easier. So that's one way of simplifying cross-component and app-wide state management. Redux solves the same problem. So both React Context and Redux are there to help us manage such cross-component or app-wide states. And that of course brings up an important question. Why do we need Redux if we already have React Context for managing state that affects multiple components? So Redux is a state management system for cross-component or app-wide state, as we learned. And of course, we can then ask ourselves, but don't we have React Context for that already? React Context is a concept and a feature we already learned about and which we already used a lot in this course because it also allows us to avoid prop chains or prop drilling, and instead we can have a central place, our context and the context provider component, which we use for managing state. So why do we need Redux? React Context has a couple of potential disadvantages. And I say potential because they might not matter in the app you're building. And if they don't matter, you don't need Redux. It is as simple as that. And just as a side note, because it's also important, it's also not an either-or decision. You can also use both Context and Redux in the same application. Typically, for application-wide state, you will only use one of the two, but then you could be using Redux for the general application-wide state and still use Context for selected multi-component states which are important in parts of your application. So mixing and matching like that would also be possible. But let's not dive into that right now. Let's instead focus on the disadvantages you could be facing with React Context. But what are these disadvantages then? One potential disadvantage is that with React Context, you can have a very complex setup, and managing state with React Context can become quite complex. And that definitely depends on the kind of application you're building. For a lot of small or medium-sized applications, that will very likely not be a problem. But if you're building a large application, an enterprise-level application with a lot of components and a lot of things going on, then when using React Context, you can end up with code like this, where you have a lot of different pieces of context, a lot of different states that affect multiple components or the entire app, and therefore a lot of different context provider components which you built for managing these states. And you can end up with deeply nested JSX code like this as a result. Of course, you don't need to build a lot of different context providers though. You could just use one big context and one context provider component for managing the entire state and all the different kinds of state of your application. But that could lead in a large context provider component which manages a lot of different things and therefore itself becomes quite difficult to maintain and manage because it's doing a lot of things. You might end up with a large context that cares about authentication, theming, user input, if a modal should be displayed or not, and maybe a lot of other things as well. So that could be a downside. And if you split it into multiple contexts, you might be back to this picture. So that can be a problem. And we haven't faced it thus far in the course because we definitely didn't build a large enterprise level application in this course at this point. But you can absolutely face this problem in real React projects you might be working on. And therefore, this is one potential disadvantage. Another potential disadvantage could be performance. We have an official quote by a member of the React team who basically says that the new context, which is the context you learn about in this course, the post is from 2018, end of 2018, but still that is exactly the context we are using here, that this context, which was introduced back then, which is why the post is from that date, that this context is great for low frequency updates, like changing a theme or maybe also authentication, but it's not that great if your data changes a lot. For high frequency changes, though it's not clear what exactly high frequency means, but for changes that happen more frequently or often in general, that it's not that good for that. And this team member says that, therefore, this new context is not ready as a replacement for Flux-like state propagation. Now, this might not tell you much, but Redux is a Flux-like state management library. So he says that React context is not really a great replacement for Redux in all scenarios, in all cases. So therefore, that's our second disadvantage. Performance can be bad if you're managing the wrong kinds of state with React context. Now, therefore, to sum it up, we have the complex setup and management disadvantage because we may end up with deeply nested JSX code and a lot of different context providers, or with one huge context provider, which is not maintainable. On the other hand, we have potential performance issues because we should not use React context for high-frequency state changes. Now, I will again emphasize that for small or medium-sized apps, and even certainly a lot of big apps, this might all not matter. But of course, my goal with the course here is to teach you realistic React, which you can apply to any kind of project. And therefore, it is important to be aware of these limitations of React context, which could matter in the projects you are working on. And that's exactly why in this module, we are learning about an alternative to React context. We are learning about Redux, which does not suffer from these disadvantages. So now that we know what Redux is, basically an alternative to React context, and now that we also know why we might want to use it over React context in some apps, the big question that remains is, how does Redux work? Well, Redux is all about having one central data store in your application. And with data, I mean state. And that is super important. You have exactly one store. You never have more than one store. It's one store for all your state for your entire application. So in this store, you would store authentication state, theming, maybe some user input state you want to save, whatever it is. Whichever cross-component or app-wide state you have, it goes into this one store. Now, this might sound unmaintainable, but the good thing is that we don't directly need to manage the entire store all the time, as you will see throughout this module and the next modules. So we have this central data store. What do we do with it? Ultimately, we have data in that store so that we can use it from inside our components. Because if some data there changes, if the authentication status of a user changes, for example, we want to know about that in a component so that we can react accordingly and update the UI. For this, components set up subscriptions to our central store. They subscribe to the store, and whenever the data changes, the store notifies components, and then components can get the data they need, for example, the current authentication status, so they get a slice of the Redux store, and they can then use it. And of course, we're going to see all of that in action, in detail, in this course. So that's how we get data out of the store. But of course, since this is state, so data which also changes from time to time, we need a way of changing that data. So how do we change data in the store then? Here's one very important rule. Components never directly manipulate the store data. So we have that subscription, but we don't have a data flow in the other direction, at least not a direct data flow. Components don't directly manipulate that data in the store. Instead, for that, we use a concept called reducers. We have a reducer function. This reducer function, which we have to set up, this function is responsible for mutating, so for changing the store data. Now, one important note here, the term reducer is of course something we have heard before with useReducer, and the reducer function here is not that useReducer hook we learned about. Reducer functions in general are just a general concept. Reducer functions are functions which take some input and then transform that input. They reduce it. For example, they can reduce a list of numbers to the sum of that number. And that's just one example. But they, in general, transform inputs and spit out a new output, a new result. So that's a general programming concept which useReducer, this hook, uses, and which this reducer function, Redux, will use, also uses. Okay, so we have a reducer function which is responsible for updating the store data, and we have components that subscribe to that data. How do we now connect components and that reducer function? Because ultimately, it will of course be the components that should trigger a data change. It is, for example, a click on a button in a component that should trigger some data change. So how do we connect that? Trigger is a good word for that, because we have a third concept here. We have actions, and components dispatch actions. And therefore, we could also say that components trigger certain actions. Now, an action is really just a simple JavaScript object which describes the kind of operation the reducer should perform. Therefore, Redux then forwards actions to the reducer, reads that description of the desired operation, if you want to call it like this, and then this operation is performed by the reducer. So components dispatch actions which describe what should be done, but don't do it directly. Then these actions are forwarded to the reducer. The reducer then does what the action wants the reducer to do, and then the reducer spits out a new state which effectively will replace the existing state in that central data store. And when that happens, when that state in that data store is updated, subscribing components are notified so that they can update their UI. That's how Redux works. Now, of course, that's all nice, that's great theory, but how does that look like in reality then? How does the code we have to write look like? Well, that's what we're going to explore now. Now, for exploring the Redux basics, I have a brand new project, and this isn't even a React project. It's an empty folder in the end, just have some settings for my IDE here. Now you can therefore also just create a brand new empty folder. We don't need a React app yet. Of course, we will add one later, but for the moment, an empty folder will do. And in that folder, you can create a new JavaScript file. You can give it any name you want. I will name it redux-demo.js. Now we will execute this file with Node.js, because Node.js allows us to run JavaScript outside of the browser. And of course, we already have Node.js installed because we needed that for creating our React apps, for installing other third-party packages with NPM, and also for running our development server. So we already do have Node.js installed. And now here, in this empty folder, I will run npm init, and you should do this too. Open a terminal or a command prompt, navigate into this empty folder, and run npm init. To be precise, run npm init -y which simply answers all these default questions with yes. If you don't run it with -y, just answer them manually with yes. Now this gives us a package.json file, which is not too interesting for us, but we need it to install third-party packages. Because now we want to install Redux. For this, we can now run npm install Redux. That's the name of that package, and when we run this, this package gets installed into this otherwise empty project folder. We therefore get a node modules folder, which now contains Redux and all the dependencies of Redux. Now we're ready to use Redux here. So in the Redux demo.js file, we can now use it. Now for that, we need to import Redux. And since we're going to execute this file with Node.js, the import will look a little bit different than what we're used to. We import Redux like this. This might look strange, but that is the default Node.js import syntax for importing a third-party package. And we import Redux from the Redux package with this syntax. Now we need to do a couple of things. If you recall that slide, we will need to create that store. We will need to create a reducer function, which changes that store. We will then also need an action and a component, or since we're not using a React app yet, any other code that sets up a subscription to the store. So I think it makes sense to start with the store, since that is the central piece and concept of Redux. Now we can create such a store by using that imported Redux object, and then on that object we can call createStore. That's a method exposed by the Redux library, which does what the name implies. It creates a store. Now let's store that store in a constant, which you of course don't have to name store, but I think it's a name that makes sense given that we create a store here. And then the question is, how do we proceed? What do we do with that store? Well, that store should manage some data. And the data which it manages is in the end determined by the reducer function, because it's the reducer function which will produce new state snapshots. The reducer has the goal of spitting out a new state snapshot whenever an action reaches it. And when we run this code for the first time, the reducer will also be executed with a default action, so to say, that should spit out the initial state. So therefore, the next thing we need to add is a reducer function. And I will name this counter reducer, but the name is up to you. And that stores a function. Here I'm using this anonymous arrow function syntax. Of course, you could also create that function like this. That would also be fine. But I'll stick to the other syntax. And that's now our reducer function. It's not finished though. A reducer function is a standard JavaScript function, but it will be called by the Redux library, and it will then always receive two pieces of input, two parameters: the old or existing state and the action that was dispatched. And then this reducer function must return a certain output. It must always return a new state object. And therefore, a reducer function should be a pure function, which basically means that the same inputs, the same values for the inputs, always should produce exactly the same output, and there should be no side effects inside of that function. So you must not send a HTTP request or write something to local storage or fetch something from local storage there. Instead, a reducer should really just be a function that takes the given inputs, which are provided by Redux, and then produces the expected output, a new state object. So therefore, back in code here, this reducer function will receive the state, the current state, and the action. It receives that by default, because the reducer will ultimately be executed by the Redux library. And then we should return the new state. which will replace the existing state. Now here on the slide, I said that the output is a state object. It typically will be, because in most applications, state is more than just one single value, but theoretically it can be any kind of value type. State can also just be a number or a string, but in reality, it will most often be an object. So here we then want to return, let's say, a new object, and then this object can have any structure we want. This is totally up to us, the developer of this page. So here we could have a counter field in this object, which is 0, for example. Now this reducer would always return an object with a counter set to 0. Now that might not be too realistic though. Instead, the counter should probably be the existing counter, and then let's say the existing counter plus 1. So state.counter plus 1, referring to the existing state, which we get automatically, accessing the old counter value, which was stored in the state, and adding 1 to it for the new counter value of the newly returned state. That's now how a basic reducer could look like. Now it's this counter reducer which we pass to the createStore function, because the store needs to know which reducer is responsible for changing that store. Because keep in mind, it's the reducer that works together with the store. So the store wants to know who the reducer function is that will manipulate the data. So we now got a reducer function and we got our store. Now we also need someone who subscribes to that store, and then we need an action that can be dispatched. Now let's start with the subscription. For this, I'll add a new constant here, and I'll name it counter subscriber, and this will hold a function. And again, you could of course also write this with the function keyword if you preferred that. So the subscriber is a function here, which does not get any parameters, but where we then inside of the function can reach out to the store and call getState. GetState is a method which is available on the store created with createStore. And it will give us the latest state snapshot after it was updated. So this subscription function will soon be triggered whenever the state changes. And then when it is triggered, we can get that latest state after it was changed with the getState method here. So then we have that latest state here, and we can just console log that state here. Now we just need to make Redux aware of this subscriber function and tell it that this function should be executed whenever our state changes. And we do that by reaching out to the store and calling the subscribe method on the store, another method which exists there. The subscribe method then wants such a subscriber function. So the subscribe method expects a function which Redux will then execute for us whenever the data in the store changed. So here we now pass the counter subscriber to subscribe. Important, we don't execute counter subscriber here, we just point at it. Just as we did not execute counter reducer here, but just point at it. Because both the reducer as well as the subscriber function will be executed by Redux. Now we got a subscriber and we got our reducer. What we don't have is an action. Nonetheless, let's save that file and then open up the terminal or command prompt. Here I'm using the integrated one. And then you can run node and then your file name, in my case, redux-demo.js. And this will execute this file and the code inside of the file with Node.js. And if you do that, you should see an error. You get an error that you cannot read property counter of undefined. Now this is an expected error. And why are we getting it? Well, we are creating a store here, and that store has a reducer as it needs to. And in that reducer, we return a state object, which sets the counter to the old state counter plus 1. The problem is that when that store is initialized, Redux will execute this reducer for the first time. So this code will then run when the store is created. The problem is that at this point of time, state is undefined. We have no existing state because it's the first time this is executing. That's why we should give state, this state parameter, a default value, which is assumed if it would otherwise be undefined, so that for the first time this runs, it does have a value. If it then runs thereafter, and we do have an existing state, the default value will not be used. But here, for the first time, we want to have a fallback default value which will be used. And here I'll set my default value to an object which has a counter property which is 0 initially. With that change made, if we save that, and we now try this again, we again run node redux demo.js, now this works. But we don't see anything in the terminal. We don't see any output. The reason for this is that we do have a subscription here, but we haven't dispatched any actions yet. Yes, there is this initialization action kind of dispatched by Redux, but that does not trigger our subscription here. We could, of course, still get our initial state by just console logging store.getState here if we needed that initial state as well. If I log this here after the store is created, then we see the initial state being output here. It's an object with a counter value of 1, y1, because the default is 0, and when this runs for the first time, we increment it by 1. That's why this is our new state thereafter, after the initialization. We could do that, but I don't even want to do that here. Instead, let's now create and dispatch an action. For this, we again use that store object, and on that object, besides getState and subscribe, we can call dispatch. And dispatch is a method which dispatches an action. Now, an action is a JavaScript object. It's a JavaScript object with a type property, which acts as an identifier. Typically, you use a string here, and then this should be a unique string, so that every action, every distinct action which you dispatch leads to different things being done in the reducer. Currently, we have no code to do different things, but we're going to add that soon. So we dispatch such an object, and here we could give this a type of increment for incrementing the counter. In its simplest form, that is all we need. Now with this, if we save that without doing anything else, if I execute the Redux demo.js file again, we get this output, counter2. We get this output because it is 1 after the initialization, as we saw a couple of seconds ago. And now we dispatched a new action which caused this reducer function to run again, and therefore the counter was again incremented by 1, which is why we now see counter2 here. That is in a nutshell how Redux works. But of course, that's not all it's able to do, because currently the type of action we're dispatching here has no effect at all. So let's take a closer look at that as well. We are dispatching an action here, and that action has a type of increment. Typically, when using Redux, the goal is to do different things inside of the reducer for different actions. And that's why you get the action as a second argument here. You get the current state, and then the action that was dispatched that caused this reducer to run. And therefore, in the reducer, we can of course look into this action. We can check if the action type is equal to increment, for example. And if that's the case, then let's say I want to return this incremented counter. Otherwise, if a different action, like the default initialization action, was dispatched, I want to return the unchanged state, let's say. And that will also change the value we have in our state here, because now for the initialization, we will not increment the counter, but return the unchanged default state. And then for the increment action, we will return the updated counter. So with this little change made, if we execute this file again, we now have counter 1 here because for the initialization, it's no longer incremented. And we can, of course, also dispatch other actions. We could dispatch an action of type decrement. So with an identifier of decrement. Then we just need to add the appropriate code here. If action type equals decrement. And then just return our new state object where counter is set to state counter -1. Like this. If we do this and save this and run our file again, we have counter 1, counter 0 as outputs. This first output is coming from our subscription after the increment action. And then we change the state again, hence the subscription triggers again, and therefore we now see counter 0 because we decrease the counter here. That's how Redux works. Now there is a bit more to it and more things you can do, but that is the heart of Redux and of how it works. Obviously, we're not using it with React here, but that is how Redux works no matter how you use it. And it indeed isn't a library restricted to React. You can use Redux in any JavaScript project. There even are implementations for other programming languages as well. But of course, here we are going to use it with React though. And therefore, in the next lecture, let's now explore how we would use Redux in a React application. So let's now apply what we learned about Redux to a React application. Attached, you find a simple starting React application, which will bring something like this onto the screen once you run the dev server, and you simply need to download it, extract it, run npm install, and thereafter npm start to bring up that dev server. And in this application, in this simple demo project, I prepared a couple of components, which we will use throughout this module. And we're going to get started very simple by transferring this counter example, which we saw outside of React in the last lectures, to this React application. Now for this, actually we can quit the dev server right away and install the Redux package, because we still want to use Redux and I haven't installed it yet in this new project. But Redux isn't the only thing we'll install. We will install that, but as I mentioned, Redux is not React specific. Redux can be used in any JavaScript project and it doesn't know anything about React and doesn't care about React. Now, to make working with Redux in React applications easier, there is a second package which we should install, the React-Redux package. This is a package which makes connecting React applications to Redux stores and reducers and so on very simple. It will, for example, make it very simple to subscribe components to the Redux store. So you should install these two packages into this React project, and once that is done, we can continue. So once that completed, I will bring up my dev server again, and now it's time to get started with Redux here. Now to get started with Redux in this React application, I will create a new folder in the source folder, and I'll name it store. This is not something you have to do, it's just a common convention to store your Redux-related code files in a store folder in the source folder. And in there, I'll just create an index.js file. This file name is also up to you, into which I'll put my Redux logic here. Now in there, I, in the end, for the moment, want to repeat what we did before already. Create a store, create a reducer for the counter, and then not subscribe though. We'll not do that. But we want to create the store, we want to create the reducer. And that's of course also a great practice for you. Without looking at the last lectures, try to create that store on your own and try to create that reducer for the counter, which has an increment and decrement action which is supported. So basically what we did before, without looking at those lectures. Try to do this on your own first. We'll do it together after a short pause, which you can use to pause the video. Were you successful? Let's try it together. We want to create a new store, and for that we need to import something from Redux. Now, since we're back in React, our import statements again look like this now. And here we can import Redux from Redux, or we can also pull out specific things from the Redux library with this import syntax. And we can then, for example, import the create store function. Now, once that's imported, we can call it to create a new store and store that store in a, well, store constant. Now, you did learn that create store wants a pointer at a reducer function as a parameter. So I'll set up my counter reducer here, and that then is a function which gets the existing state as a first argument, and then the action that was dispatched as a second argument. Now we can give this state a default value so that when the reducer is executed for the first time, we have an initial state. And here I'll stick to the exact same state we used before, counter set to 0 in an object. And in the function body of the counter reducer function, we now want to handle different actions, increment and decrement, and then return different state snapshots. So here we can check if action type is equal to increment, in which case I want to return a new object where the counter is set equal to state counter plus 1. Else I check if action type is equal to decrement, in which case I want to return an object where the counter is set to state counter minus 1. Or if we make it into neither of these if statements, I'll return the unchanged state. So the state which I get here, I return that without any changes in that case. So now we can use this counter reducer function and point at that function here in our store when we call create store. This now creates our Redux store. Now previously we did now subscribe here and dispatch from inside this file, and that's now not what we want to do here. Instead, now I want to connect my React app to this Redux store so that the components of that app can dispatch and listen. And that's now the new part. For this, I'll start by exporting this store, which we created here, as the default export of this file, so that we can use it outside of this index.js file. And now I want to connect my React application to that store. For this, we need to provide this store to the React app. And since, remember, we only have one Redux store, we only need to provide our store once, the only store we have. The question just is, what does provide mean? To provide our Redux store to the React app, we typically go into this index.js file, where we render the entire app. So to the highest level we can go in our React application, to the top of our component tree, where we render this root component. And now here we can import from React Redux. So not from Redux, but from React Redux. And what we import here is now the provider component. This is actually a component. And now we wrap our root component with provider. A little bit as we used our own context provider components, if you recall that from earlier in the course. We also built our own context provider components using React Context, and we wrapped our app or a part of our app with that as well. We're basically doing the same here, and you don't have to use provider on this highest component level. You could also wrap nested components with provider, but only wrapped components and their child components and the child components of the child components and so on, only those components will have access to Redux thereafter. And if the vast majority of your components need access to the store, if maybe your entire app needs access to the store, you should typically provide on this highest level. Now, just by wrapping provider around app, we're not telling React Redux and React, therefore, which store we want to provide. Sure, we only have one store, but that's stored in this index.js file. React Redux, of course, doesn't know that that file holds our store. Instead, we have to import our store from store index in this case. So that store, which we're exporting in there, we're importing this into index.js. And on this provider, which we import from React Redux, we have a store prop, which we have to set. And this wants a value which is our Redux store. So this store, which we're importing here, we're setting this as a value for the store prop on this provider component. And that now provides our Redux store to this React app. Now, on its own, that doesn't do much. Now the store is provided, but that doesn't change anything at the moment. But now our components in this app, the app component and any other child components, can tap into that store. They can get data out of the store. They can set up a subscription to that data, to be precise. And they also can dispatch actions. And that's what we're therefore going to do next. Let's say we want to utilize this provided store not in the app component, but in the counter component which I rendered there. That's this counter component in the components folder. We got more components there, we'll use them later. For the moment, it's the counter component that matters to us. Now that's the component you're seeing on the screen here when you're running your dev server. It shows us basically a container where we want to output the counter value. We got a toggle counter button for hiding or showing the counter. Now here I want to start by outputting the current counter. And for this, we need to get access to our Redux store and to the data in there. And we again do that with help of the React Redux library. So from React Redux, we again want to import something. And the something which we are importing is a React hook, a custom hook made by the React Redux team. The use selector hook. There also is a use store hook, which we could use as well, which gives us direct access to the store. But use selector is a bit more convenient to use because that allows us to then automatically select a part of our state managed by the store. So I will use selector here. Now, if we would be using a class-based component and not a functional component as we are here and as we are in the majority of the course, then there also is a connect function which we could use instead. This function can be used as a wrapper around our class component to connect that class component to the store. I'll come back to that later. For the moment, we'll focus on use selector. So here in this functional component, we can now get access to the data managed in our store by using use selector. We call this, and now we need to pass a function to use selector. A function which will be executed by React Redux, a function which then basically determines which piece of data we want to extract from our store. Of course, at the moment, we have a very simple state, just an object with a counter property. But in bigger applications, you will have more complex states with tons of different properties, maybe nested objects and arrays, and therefore being able to just get a slice, just a tiny part of that overall state object in an easy way is worth a lot. And that's what useSelector allows us to do. For this, we should pass a function to it, a function which will receive the state managed by Redux, and then we return the part of the state which we want to extract. So here, for example, state.counter. Again, this function will be executed for us by React Redux. It will then pass the Redux state, so the managed data, into this function when it executes it, and then basically executes this code to retrieve the part of the state which you need in this component. And then useSelector, therefore overall, gives us that returned value. So we get a counter constant, which is the counter managed by Redux. Now the great thing is that when you use useSelector, React Redux will automatically set up a subscription to the Redux store for this component. So your component will be updated and will receive the latest counter automatically whenever that data changes in the Redux store. So it's then automatically reactive, and changes to the Redux store will cause this component function to be re-executed. So you always have the latest counter. That's why useSelector is a very useful hook, and why it is the hook we use for getting data out of the store. If you ever would unmount this component, if it would be removed from the DOM for whatever reason, React Redux would also automatically clear the subscription for you. So it manages that subscription for you behind the scenes. Now that we got this counter, we can use it down there to output the counter value like this. And if we now save this, we therefore now see 0 here. And that's how we can get access to data managed by Redux. Of course, the question now is how we can change that data. How can we dispatch actions? Now for dispatching actions, I first of all want to have two new buttons here which allow me to dispatch actions for incrementing and decrementing. So here I'll add a new div, and in that div I'll just add two buttons. The first one says increment, the second one says decrement, so that we have these buttons. And now to add some spacing, I'll quickly dive into counter module CSS and add this selector .counter button, which selects these buttons here. And I'll just give them a margin of 1 rem in all directions, just so that we have some spacing. Now, with that added, with that set up, now we want to wire up those two buttons, increment and decrement, so that they do increase or decrease the counter by 1. Now we know that we need to dispatch an action for that, but how does that work from inside a React component? Well, there is another hook which we can use, the useDispatch hook. When we call useDispatch here, we don't pass any argument to it, but instead this gives us back a dispatch function which we can execute. So dispatch here is a function which we can call, which will dispatch an action against our Redux store. So therefore now I'll add two new functions here in this counter component, the increment handler and the decrement handler. So two new functions which will wire up to the buttons. And in the increment handler, we want to use this dispatch function and execute it to dispatch a new action, and then do what we learned. An action is an object with a type property. So let's add such an object here as an argument to the dispatch function call, so that we dispatch this specific object. And then the value for type should be one of the identifiers we use in our Redux store reducer. So here in the reducer function, we handle the action type increment and the action type decrement. So we should dispatch one of these two identifiers. Of course, exactly these identifiers, without any typos or changes. So back in counter, here I'll dispatch increment. And then here in the decrement handler, I'll dispatch an object with a type property with a value of decrement. Now we need to wire up those two functions to the buttons. So on this first button, we add a on click prop and point at the increment handler. And on the second button, we do the same for the decrement handler. And if we do that and save this, if we now click increment, you see the counter increases. And if we click decrement, it decreases. So now we're able to use what we learned about Redux in this React demo, in this React component here. Now, even though it's not the focus of this course, because it's not the common way of writing components, I wanna briefly talk about class-based components instead of functional components. Because whilst nowadays we typically do use functional components only, there still are a lot of projects out there that do use class-based components instead. And there, of course, also are simply people who prefer that, and there's nothing wrong with class-based components. Therefore, I also want to show you how this counter component would look like if we would build it as a class-based component. For this, I'll add a class named counter here, and that class needs to extend the React component object, the React component class. So I'll import from React, I will import component like this. And with that imported here, we extend component. Now that's what you learned in a separate module about class-based components. That's how they work. Now in here, we then can add a constructor to initialize our state, but here we don't have any state. Instead here, we then add the render method, which should of course return this JSX code. So I'll copy that and return this JSX code here. But now we need to add increment and decrement handler methods, a toggle counter handler method, even though we're not doing anything with that yet. And we then need to make sure that we get access to our counter. So let's add a couple of methods here. Let's start with the increment handler method, then the decrement handler method, and also the toggle counter handler method. And this is how we can add methods in JavaScript classes. Now down here, we now want to hook this up correctly by using this increment handler and this decrement handler and this toggle counter handler, referring to these methods which are part of this class. And then the question now is, how do we get access to Redux here? In the functional component, we used hooks, use dispatch and use selector. But hooks are not usable in class-based components. Now, I briefly did mention it before. React Redux also exports a connect function, which is a function that helps you connect class-based components to Redux. Actually, you could also use it on functional components, but for functional components, using these hooks is simply more convenient. But no matter if it's a functional or class-based component, you can use connect, and therefore we will use connect here on this class-based component. How do we use it? When we export our counter, we don't export the counter component like this. Instead, we call connect, and now connect, when executed, will actually return a new function as a value, which we then execute again. And then we pass our component to that returned function as our argument. So this can look strange, but connect is a so-called higher order component. We execute the connect function, it then returns a new function, and we execute this new function as well. And to this returned function, we pass counter. Now, why do we do it like this? Because to connect, when we execute this, we also pass something. Connect also wants some arguments. Connect also wants some arguments. It wants 2 arguments to be precise, and both arguments are functions. I'll write them separately here. The first function is a function that maps Redux state to props, which will be received in this component then. Hence, we call this function map state to props. That's not a name you must use, but a convention which you will see in a lot of projects. Now, this is a function which receives the Redux state, and then this returns an object where the keys will be available as props in the receiving component, so in the counter component, and the values of those keys, that is then the logic for drilling into that Redux state. So here we could expose a counter prop by using counter as a key here. This key name therefore is up to you. And the value is state.counter. So we then pick the counter value from the Redux state and bind that value to the counter prop. That's what we do here in the end. And that's of course similar to what we do with use selector. Here we also get the state and drill into the state to get the counter and then store that in a counter const. That's basically the equivalent when not doing it with hooks, but with the connect function. Because now map state to props is the first argument we pass to connect. The second argument is another function, which is typically called map dispatch to props. It's the equivalent to use dispatch. Now the idea is to store dispatch functions in props, so that in the counter component we have certain props which we can execute as a function, which will then, when executed, dispatch an action to the Redux store. For this, map dispatch to props receives the dispatch function as an argument automatically, just like map state to props. The map dispatch to props function will be executed for you by Redux. And then in here, we also return an object where the keys are prop names, which we can then use in the component. So for example, increment as a name. And the value is then another function in which we call dispatch and then set up our action. For example, here, an action where the type is increment. This might look strange, but in the end, this ensures that in the counter component, we'll have an increment prop, which we can use. This prop holds this function, so we can execute this function from inside the component thereafter. And when we do so, we will call dispatch and dispatch this action. And we can therefore also do this for decrement and dispatch the action with a type of decrement. And now that's the second argument we pass to connect, a pointer at this map dispatch to props function. These are just pointers. We don't execute map state to props or map dispatch to props here. We just point at them. They will be executed for us by React Redux. And when using connect, React Redux will still set up a subscription and manage a subscription for you. It will do all of that. It's just an alternative to using the use dispatch and use selector hooks. And obviously that's a bit shorter and easier, I would say. But if you're working with class-based components, you can't use hooks, and then this is your equivalent. So therefore now, to take advantage of these props which we map into our component in the counter component, in increment handler, we can now execute this .props increment, because on our props in this component, we'll have a prop named increment because of our mapping here. And in the decrement handler, we therefore can execute this props decrement. And here in our JSX code, where we want to output the counter, we would use this props counter because we received a counter through props because of us mapping this counter state to the counter prop here. Now, to make sure that everything works, because JavaScript works the way it does, we need to call bind here on the increment and decrement handler bindings in JSX and bind this to make sure that the this keyword inside of these methods refers to the class. So that's something we need to add here. And then we can comment out this functional counter component so that we don't have the same name being used twice in this file. And if we now save this, it's reloaded and we can still use it as before. It works as before, but now with a class-based component. Again, class-based components are not the focus of this course, but they do exist, they are valid, they are still getting used in a lot of projects, and therefore you should know how to connect those to Redux as well. Nonetheless, I will now again comment out all that code here essentially, and comment the functional counter component back in, and then export this functional counter component again, and get rid of all the imports which we don't need anymore, but I'll keep the commented code down there so that we have it for reference. And now you learned about both. Now we will stick to functional components, but it is worth knowing about class-based components and the connect function as well. Let's dig deeper into Redux. Up to this point, we only dispatched simple actions. They only had a type, nothing else. In reality, you often want to dispatch actions that also carry an extra value. Let's say we want to add a new button to the counter component, which says increase by 5. We could of course also add a decrease button, but let's stick to the increase button for now. Now, even though it has this label, it of course only increases this by 1. Because I still just call the increment handler here and dispatch increment. Of course, we could now go to the store and prepare our reducer for another action type, which is increase by 5, where we then return our updated state, where we increase the state counter by 5. But that's not scalable. We can't predict all possible values we might want to support. The counter, of course, is just a dummy example. But if you're using this in a real project, which we'll do later in the course, and you need to work with any user input, for example, you can't hard code those values here in your reducer. Instead, the action which we dispatch and which reaches the reducer often needs to carry extra data. So that, for example, we have an increase action type here, and that action type does not increase the counter by a fixed number, but instead we expect to get the value by which we want to increase from the action. In there, we could say that we expect to get the value property or have an amount property or whatever it is, and then we want to increase by that. That would be a reasonable expectation, and that's of course a very common scenario, hence Redux and React Redux supports it. Back in the counter, we can now add a new function here, the increase handler, and in there we again want to dispatch, but now the action which we want to dispatch will not just have a type, it will have one and the type is increase, but it can now also get an extra payload, extra data which it carries. For example, an extra amount property. And this property name is entirely up to you. It's your action, it's your action object. You can add whichever properties you want. So here I'll add an amount property and set amount to 5 here. Of course, 5 is therefore still hard-coded here in this function, but that's just a demo. Of course, this value could be coming from an input field. Here it's hard-coded, but now we can point at the increase handler here. Now we add this extra payload to the action, and in our store in the reducer function, when the type is increase, we do expect this amount field on the action. Therefore, of course, you need to make sure that the property you're accessing here on the action in the reducer has exactly the same name as the property you add to the action when you dispatch it. Otherwise, you won't be able to extract this data. Hence now if we save this and reload this, we do increase by 5. But now this is very flexible. We can easily change this to 10, and for completeness sake, change the button text to 10 as well. And now we increase by 10. It works just like that, because now the reducer is dynamic. It extracts an action payload. And action payloads are very common, often needed, and as you see, it's super easy to add them. It's just an extra property which you add to your action objects. So now we already learned quite a bit about Redux, but up to this point we always just worked with our single counter value. Now I got this toggle counter button here, and when it's clicked, I want to make sure that the counter is hidden, and when it's clicked again, it should be shown again. Now for this, of course, we could use state. So we could set up some local state in this component, which we manage with useState, not with Redux. And that would be the proper way of doing it, because showing or hiding the counter is something which only is interesting to this component, not to any other part of the application. But the same could be said about our counter. We are only using the counter in this component here. So the counter technically also is local state. But this is just a simple demo to get started. So let's assume that both the counter as well as the state, whether the counter should be visible or not, is a global state, which is also interesting to other components, even though that's not the case here. As we progress, once we know these basics, we will of course also work on demos and projects where this then really is the case. But for the moment, let's assume it. So when we click this button, the toggle counter handler is fired, and then here we want to dispatch an action which changes some state in Redux, which controls whether this counter div is shown or not. For this, we need to add a new state, a new piece of data to our Redux store. And how do we now do that? Well, to add a new piece of data, we need to go to our reducer in the end and just add it to all these state snapshots which we are producing. Let's start with the initial state snapshot. When we start, besides having a counter which has a value of 0, I want to have a show counter field which has a value of true or false. That's up to you. And to keep this a bit more readable, I'll extract that and store that in a constant named initial state like this and assign initial state here then, just to make this a bit easier to read. Now when we increment, we are changing the counter. We don't care about show counter. We still need to set the show counter property here though, because we are returning the overall state object, and Redux won't merge your changes with the existing state. It instead takes what you return and replaces the existing state with it. More on that in a second. But for the moment, let's just accept it, and let's set show counter here to state show counter. So to the value we currently have in our state. Because for increment, we don't want to change it, so we will just take the existing show counter value. And we can do the same here for increase, because there we also want to keep the existing show counter value. And do the same for decrement here. But now I will also handle a new action type. And by the way, since we have many if statements here, we could also use a switch case statement, but I will stick to multiple if statements here for now. And in this new action type, I will check for, let's say, toggle. Now the identifier, just like all these identifiers, is up to you. I'll go with toggle and then return a new object. Here we now want to change show counter and set it to the opposite of what it was before. If it was true, we want to set it to false. If it was false, we want to set it to true. We can do this by simply adding an exclamation mark and then accessing state show counter. this will invert the value. Now for the counter itself, we want to keep the existing state because we don't want to change this here for this action. So we just set counter to state counter. Now we also support this new toggle action type, and hence back in counter.js, in the toggle counter handler, we should dispatch such an action. We dispatch a new action object where the type is toggle. Now we can take advantage of this toggle state, so of the show counter state, and for that we need to get access to it. So also in the counter, we again call use selector. We can use this multiple times to retrieve different pieces of data from the state. And here I'm then interested in my show counter piece of data. And I'll store that in a show constant. The constant name, of course, is up to you. Now again, that will then always update and the component will be re-evaluated whenever that data, which we're accessing here, changes. So now here with show extracted, we now can render this div here conditionally by checking if show and only rendering the div if show is truthy. Like this. If we now save this and reload, if I click toggle counter, it's gone. If I click this again, it's there again. I can still increase it even if it's hidden, but it only shows up when I click toggle counter. So that now also works, and that is how we can manage multiple different pieces of data in our state. Of course, this data is still kind of connected. We have the counter and then the state whether we want to show it or not, but it's two totally different values which are changed in totally different ways. So therefore, that is how we can manage multiple pieces of data. Now let's talk about the objects which we are returning in our reducer, in our Redux reducer. I mentioned in the last lecture that we always return a brand new snapshot, a brand new state object, which Redux will use to replace its existing state with. So the objects which we return in the reducer will not, and that's super important, will not be merged with the existing state. They will overwrite the existing state. So if we, for example, don't set show counter here when we increment it, because we forgot to add it here, if we do this, if I click increment, you see I close my counter. I close my counter when I click increment, even though I shouldn't, because I don't set show counter here. Hence, it's basically removed from the object, and it has a value of undefined, therefore, and undefined is treated as falsy, so we don't render the counter then. And that's, of course, a side effect which we don't want. That's an error. So we must always set all the other states when we update a piece of state, because we overwrite the old state. Now that brings up one question. Why do we need to return a new piece of data here? Why can't we just use the state, which we're getting as an argument, access counter, and increment it like this, instead of returning? Or maybe we do it like this, and then we return state. And when we do that, we change state before we return it, and then we just return it again. Well, if we do that, and we reload, everything works. So it's not easy to see that this is wrong, but it is, even though it works. This is something you absolutely must not do when working with Redux. You should never, super important, never mutate the state, the existing state. You should never change the existing state. Instead, always override it by returning a brand new state object. And because objects and arrays are reference values in JavaScript, it's easy to accidentally override and change the existing state. You could, for example, think that you can do something like this, and then you return a new object where you then do set the counter to state.counter and show counter to state.showCounter. We can do this because we changed the counter here, And then we return a brand new object. Everything's good, right? Well, again, that will work. If I reload, it works, but it's still super bad because we still mutate the existing state because objects and arrays are reference values in JavaScript. And in case it's not clear to you what I mean by that, attached you find a link which leads you to an article and a video where I explain this in depth. Now, when working with Redux and its state, you must never mutate state like this. Never change the original state which you're getting. This can lead to bugs, unpredictable behavior, and it can make debugging your application harder as well. So even though it doesn't lead to a bug here, it can have unwanted and unexpected side effects in bigger applications where your state gets out of sync and suddenly the UI is not reflecting your state correctly anymore. And hence the simple rule is never mutate your state like this. Always return a brand new object where you copy any nested objects or arrays, if you have any, and create brand new values, as we're doing it here. By updating our state like this, we create a brand new object where we don't change anything. And especially when you have a state with nested objects and arrays, it's easy to accidentally mutate your existing state, and therefore you should be super careful that you do this in an immutable way, that you never accidentally mutate your existing state, but you copy any objects which you added. So you always create a brand new object or array whenever you need to update data. You never just dive into an existing object and start manipulating its properties. Always copy and create new objects. Now at this point, it might look a little bit too early to emphasize it like this, because this is a fairly simple state here, but it is super important, easy to mess up, and something you should know right from the start, which is why I am emphasizing it here. So by now we learned a lot about the important basics of Redux and how we use it. Now the more complex our projects become, the more complex it can get to use Redux correctly. Now the good thing is that in this course you will of course see many examples, also bigger projects than this one, but another good news is that there is a slightly easier way of using Redux as well. Now I wanted to show you the core foundation first, so that you understand how it works, but now I want to dive into an approach that's a bit easier to set up and maintain. Before we do that though, let's identify a couple of potential problems we could be facing here if our application would continue to grow. So if we manage more and more state with Redux. One potential issue can be our action types, these identifiers. I mentioned it before, you of course have to avoid typos. If you dispatch an action, you have to make sure that you don't mistype the identifier here, otherwise it of course won't be handled by the reducer or won't be handled correctly. Now that's not a problem in a small app like this, but in bigger applications, with a lot of developers working on the app and with a lot of different actions, it's super easy to imagine that you could mess up one of these identifiers. You could even have clashing identifiers there, so clashing identifier names. So therefore, having some way of defining those identifiers once and then reusing them would be nice. And that is something we can do with JavaScript and something I will come back to in a second. Another potential problem is the amount of data which we manage here. The more data we have, the more different pieces of state we have, the bigger our state objects get. And that means that we need to copy a lot of state. When we update the counter, we still need to copy and keep all the other state properties. And it also means that this reducer function gets longer and longer. And all of a sudden, we might have an unmaintainably big Redux file. And you might recall that I brought this up as one potential disadvantage of React context, if we put everything into one context provider file. Now, we can end up with the same problem with Redux, but thankfully there are solutions for that with Redux. Another potential problem we could be facing is the state immutability, which we have to respect. I talked about it in the last lecture. We have to ensure that we always return a brand new state snapshot and that we don't accidentally change the existing state anywhere. And especially if you have more complex data with nested objects and arrays, it's easy to mess this up and accidentally change some nested data, even though you didn't want to. So it would be great if we would have some help with that as well. And if we could ensure that we don't accidentally manipulate nested data or anything like that. Now, for all those problems, there are solutions we could implement on our own. For example, for ensuring that we have unique identifiers and we don't mistype, we could create constants, let's say a constant named increment, which stores this identifier, and we then export this constant, and we check that constant's value here, and we then import and use that constant in the counter component, so that here we use the type increment and we just import increment. So we import increment from going up store index. That is something we could do to fix this issue. And these are approaches which we typically used in the past with Redux. There also are solutions for splitting your reducer into multiple smaller reducers so that you don't get this large, super big file. And there also are solutions and third-party packages which allow you to automatically copy state and ensure that you don't accidentally edit it. But we actually don't need to dive into those various solutions anymore. Instead, there is another library called Redux Toolkit, and you can just Google for Redux Toolkit to find its official page. It's actually developed by the same person or the same team as React Redux and Redux itself, and Redux Toolkit simply is an extra package which makes working with Redux more convenient and easier. You don't have to use it. Unlike Redux and React Redux, which we installed before, you don't have to install and use Redux Toolkit, but if you use it, certain things will get easier. And therefore, in the next lecture, we're going to get started with Redux Toolkit. So let's now get started with Redux Toolkit, and for that I'll quit my dev server, and then npm install @redux.js/toolkit. That is simply the package name. You also find this in the official docs. So we execute this, and this will then install this Redux.js toolkit package. Now, when you install that, you then thereafter can also uninstall Redux, so the Redux library itself, because that is already included in Redux Toolkit. So you could now remove this Redux entry here from package.json. Now with it installed, we can restart the development server. And now the question is how we use Redux Toolkit. Well, we do use it here in this store folder in the index.js file, because Redux Toolkit simplifies a couple of aspects of working with Redux. And let's start with the reducer and also indirectly with the actions. Here at the top in the index.js file, we can import something from @redux.js/toolkit, and that something is the create_slice function. There also is a create_reducer function, which would also allow us to create a reducer with certain enhancements, but create_slice is even more powerful than create_reducer, and it will simplify a couple of aspects in one go. Now, once we imported it, we can call create_slice here, and I will call it below my initial state object. And then create_slice wants an object as an argument. Now, what we do with create_slice is we are preparing a slice of our global state. And when we have different pieces of state which are not directly related, let's say an authentication status and the counter status, we could create different slices, potentially also in different files, to make our code maintainable. Now here we only have counter related state, and I would say that the counter and show counter belong kind of together, so I will create one slice for now. Now every slice needs a name, an identifier of that piece of state, so to say. And here I'll name this counter, but the name is up to you. It doesn't have to be this name here, it can be any name you want. Next, you need to set up an initial state. And here I want to set my initial state equal to that object, or I therefore just point at initial state, so at this constant, and use that constant's value as a value. Or we even use modern JavaScript syntax, omit this part, and let JavaScript behind the scenes automatically expand it to this code again. So with that, we're setting the initial state of this state slice to this initial state. And then we also need to add reducers. Reducers is again an object, a map, you could say, of all the reducers this slice needs, this state slice needs. Now here in this object, you can now simply add methods with any names of your choice, though those names will become important later. And here I'll add an increment method, I will add a decrement method, I will add an increase method, and I will also add my toggle counter method, let's say. So 4 methods, because I had 4 different if cases in my reducer before. Now every method here will then automatically receive the latest state. These methods will be called for you by Redux, and they will receive the current state. Also to the action, and we'll use that in a second, but actually here we don't need the action because these methods will automatically be called for you depending on which action was triggered. So we don't need to write our own if checks anymore. Instead, we'll soon be able to identify these different reducers and dispatch actions that target these different reducers. So we now don't have to write our own if checks anymore, which also reduces some boilerplate code we would have to write otherwise. Now in these methods here, in the reducers map, we now also can do something else than we did before. Now here we are allowed to mutate the state. So here we can set state.counter ++, for example, for incrementing it. Now this was forbidden before, and I emphasized that it is forbidden. I also did emphasize it because here it seems to be allowed. But the important part is the word seems. We still must not manipulate the existing state. But the good thing is, when using Redux Toolkit and its functions like create slice, we can't accidentally manipulate the existing state. Because Redux Toolkit internally uses another package called immer, which will detect code like this and which will automatically clone the existing state, create a new state object, keep all the state which we're not editing, and overwrite the state which we are editing in an immutable way. So we still have immutable code here, even though it doesn't look like it because of this internally used package. And therefore, we as a developer have a much easier time working with Redux because we don't have to create a copy manually and keep all the code we're not changing. Instead, we just change the code we want to change, and internally it's translated into immutable code. Therefore, in decrement, we execute state.counter-, and here for increase, we now need a payload. We now need extra data. So how does that work? Now, when using Redux Toolkit, we of course can still have reducers that listen to actions that have an extra payload, extra data. Because these reducer functions here don't just receive the state, they also still do get the action. We just don't need to accept it in the other two reducers because we don't need to do anything with the action in there. But now here, if we need some data that's attached to the action, then we can still accept it as a parameter and use it in the reducer function in the reducer method. So therefore now I can set state counter equal to state counter plus action dot amount. So basically what I did down here as well. Now again in this mutable looking way, which isn't really mutating the state. Now for toggle counter, we don't need an action payload. Here we just get the state and set state.showCounter equal to not state.showCounter to invert this value. So now we created this slice, and writing that code is certainly quite convenient and shorter than what we had to do down there. But how do we now make our store aware of that slice? How do we use that slice? And how do we then dispatch actions against this slice? Now to use our slice, we first of all need to use the return value of calling createSlice. Because here we get back our counter slice. Now this name is up to you, but it's a slice of our global state, the slice which is responsible for working with our counter. Now we want to register this with our store. So first of all, we can get rid of our old counter reducer here. We don't need that anymore. So let's remove it to make this a bit more readable. And now here to create store, we could pass our counter slice dot reducer. With that, we get access to the reducers set up in the slice. Even though it's dot reducer, it's basically a big reducer with a couple of if statements that trigger those different reducer methods depending on the action type, and we would be good to go. We just couldn't dispatch actions right now, but in theory, we would be good to go like this. But if we have bigger applications with multiple state slices, we would face a problem if we try to do it like this, because there can only be one reducer passed to create store, and when we have multiple slices, we have multiple reducers, which we access with dot reducer on the different slices. Now with standard Redux, there is a combine reducers function, which we could use for that. But we can also ditch Redux here and instead import another function from Redux.js toolkit, which will make that a bit easier. We can import the configure store function. Configure store, like create store, creates a store, but it makes merging multiple reducers into one reducer easier thereafter. So here we can now call configure store, and to configure store we now pass an object, not a reducer function but an object. It's a configuration object expected by configure store. A configuration object where we then set a reducer property, and that's an expected property by configure store. Reducer, singular, and not reducers, plural, because still, no matter if we use create store or configure store, Redux wants one main reducer function, which is responsible for the global state. However, with configure store, the value for reducer can be a single reducer. So we can, for example, use counter slice dot reducer to use the reducer from that counter slice, which combines all those reducer methods defined in that slice. We can use that as a global main reducer. And here that would make sense because this is the only state slice we have and therefore the only reducer we have. But if we had multiple state slices in a bigger application, something we're going to see later, then alternatively, as a value for this reducer key, we could also set an object, and in that object we can set up any keys of our choice, so any property names of our choice, and the values of those properties would then be different reducer functions. So we would create a map of reducers, you could say. And this map is then set as a value for the main reducer, and behind the scenes configure store will merge all those reducers into one big reducer. So it will merge them for us. And that's an alternative we can use, not an alternative we will use here though, because here we only have one reducer, so we can directly assign that reducer from the counter slice as our main reducer for configure store. Now the question is, how do we dispatch actions? Because we don't have our own if checks, we don't know what the identifiers for our actions should be. We just have these method names, but how do we now know what to dispatch? Now for dispatching actions, create slice has got us covered. It automatically creates unique action identifiers for our different reducers. To get hold of these action identifiers, we can use our counter slice and access.actions. That is then an object full of keys where the key names, increment, decrement, and so on match the method names we have in our create slice function in the reducers area. Now we can access those keys on this actions object, and with that we don't access the reducer methods defined up there, but instead we get methods created automatically by Redux Toolkit, which when called will create action objects for us. These methods on the actions object here, which we can call, will create action objects for us. Therefore, these methods are called action creators. And they will create action objects for us where these objects already have a type property with a unique identifier per action, automatically created behind the scenes. So we don't have to worry about action identifiers. We don't have to create those action objects on our own. We can tap into this actions key, into this actions object, on our created slice and execute these action creator methods, which with their name match our reducer methods to dispatch actions, which will then ultimately trigger those different reducer methods. That's how this works now. And that means that we as a developer don't have to worry about creating action objects on our own and about coming up with unique identifiers and about avoiding typos. So that means that what we could do here is at the bottom of this file, we get our counter actions like this, and we then, for example, export our counter actions. So we don't just export the store, but also our counter actions. And by doing this, we can then go to the component where we need the actions, in this case the counter.js file, and import from our index.js file here and import the counter actions, which we just exported there. And now again, that's an object which has our reducer names, our reducer method names as keys. So now if we want to dispatch an action here, all we have to do is we have to access counter actions and then, for example, here increment and actually execute this as a method, because increment is a method which, when executed, creates a full action object with the type set to this automatically created unique action identifier. So we get a full action object automatically created for us here. And I also want to do this for decrement, counteractions.decrement, and also for toggle, of course. Toggle counter. The question just is, what do we do here when we also need a payload? And the answer is, we still use our counter actions and then use this automatically generated action creator method here. But then to this method, we pass our payload data. So for example, an object with any property value pairs of our choice, or just the number by which we want to increase here. So any kind of value can be passed to increase. The only important thing to know here is how you then extract that value. Because what Redux Toolkit will do for us here is it will automatically create action objects, which it dispatches, where the type is some unique identifier generated by Redux Toolkit. And any value you pass here as an argument to this action method you're executing will be stored in an extra field named payload. And that field name is not up to you. That's the default Redux Toolkit uses here. Hence now in our index.js file, in the increase reducer, instead of action amount, we now need to access action.payload, because that is the name of the property which will hold any extra data you might be dispatching. But with that, was a lot of work, but with that, if we save all the files, if you reload your application, we can now use it as we did before, and everything works the way it did before, but now with help of Redux Toolkit. And this was certainly a bit of work to translate our code, to refactor our code to use Redux Toolkit. However, it also took quite long because I tried my best to explain it in depth. But now that we did transform our code, it's shorter, it's more concise, and it's easier to maintain. And it's also easier to now work with Redux if you have a more complex application, which we don't have yet, but which we will still get in this course. So we did now translate our Redux-only non-React example, where we also used a counter, to this React application so that there we also manage this counter state with Redux. And we actually do more than what we did initially in this module when we just got started with Redux. Now in this starting project, which I provided to you, we got a couple of other components as well, not just the counter. We got a couple of other components as well because there's more I wanna practice and teach you when it comes to Redux. And therefore it's now time to use some of these other components. In the app.js file, in this app component, let's now return more than just the counter. Let's add a fragment imported from React, this built-in fragment component, so that we can have a couple of adjacent JSX element. And let's also add our header component here. And for this, we need to import header from /components header. And let's also add the auth component here. And for this, import auth from /components auth. Now, if we do that, we have this little demo application. We still have the counter down there, and we could also remove it. It's not related to this mini demo at all, but I will leave it there so that we still have the Redux state for the counter. And now we're also going to add state for this demo application. But which state? Well, here I would like to make this login form work. Not really, we won't really add authentication here. We do this in a separate course section because there's more to it than a little bit of Redux usage. But I want to make sure that when we click login, we do switch into some login mode. And for example, what we see here in the navigation bar changes. These items and the logout button should only be displayed if we are logged in Redux. And I also want to swap this login field here, this login form, for another component, the user profile component, which has some dummy output. So we have a brand new state to manage. And unlike the counter state, which was just a basic example, the authentication state and the answer to the question whether the user is logged in or not is indeed not just local state, which matters to one specific component, but it is application-wide state, which matters to a lot of components in the application. It matters to the header, it matters to the auth component, it matters to the user profile component in the end. So therefore, this is the user authenticated state is a perfect example for a state that we could manage with React context, or since this section is about Redux, with Redux. And that's therefore what I want to do now. I want to make sure that when we click the login button, we set the user to authenticated. If we click the logout button, I want to set the user to not authenticated. And for this, in our store here, we can add a brand new state, a brand new piece of data. Now the question is where we should add our authentication data. We do have this slice which we created here, this counter slice, and in there we manage the counter and the show counter state. We could, of course, also add a new property to our state here. Let's say the isAuthenticated property and set this to false, and then add a new reducer, login, for example, a new reducer method. And in here, we then set isAuthenticated to true. We could do this, but logically it makes no sense. The authentication status has nothing to do with the counter. Whilst it would technically work, in programming, we typically want to separate our concerns. We want to make sure that this slice really focuses on the counter-related state and actions. And we should create a brand new slice for the authentication state. And that's therefore what I'll do. I'll rename this initial state up here to the initial counter state, because we will soon have more than one initial state. And therefore I set the initial state property in this slice to the value stored in initial counter state. And then we can add a new slice below the other slice, though the exact position does not matter. But we can call create slice again to create another slice. And this slice also, of course, needs an object to be configured, just as our first slice. This slice will be configured in exactly the same way, just with different values. So we add a name here and set this to auth, for example, or authentication, whatever you want. And we also want to assign some initial state here. Now we could create this on the fly here, or again create a separate constant which holds this initial state. And that's what I'll do here. I'll add a const initial auth state, which again, let's say is an object, where we have the isAuthenticated property, which initially is set to false. And then here I set initial state equal to this initial auth state value. And then we need to register our reducers, these reducer methods which can change this state. And here I think two methods make sense. A login method for, well, logging the user in, and a logout method for logging the user out. In both methods, we'll receive the current state as an argument, automatically provided by Redux, and we can then mutate this state, even though we technically shouldn't, but as I explained, we can do it here because under the hood, our code will be transformed to actually not mutate the original state, so it's safe to do that here. And we can set state isAuthenticated equal to true here in the login state, and here in the logout state, set isAuthenticated to false. And that could be our slice for the auth part. So I'll store this in an auth slice constant. Up here we have the counter slice. Now I have the off slice as a second slice. And now we want to add that to our Redux store. Now, very important, when you work with multiple slices, you still only have one Redux store. So you still only call configure store once. This does not change. And this store only has one root reducer here. But as I briefly explained earlier, this reducer actually does not just take a reducer function as an argument, but also an object which acts as a map of reducers, where you can then have any key names of your choice, for example, counter, and then point at your different reducers. Here, for example, at counterslice.reducer. And then we also add off, let's say, as a key. And then here we add off slice.reducer. And these individual reducers here will then automatically be merged together into one main reducer, which is exposed to this store. That's how we can combine multiple slices and their reducers. Now, our off slice, of course, also exposes actions which we can use, and therefore I want to expose those as well. So export off actions, which is off slice.actions. So now we added this off slice. Let's now use it in our different components. And of course, definitely feel free to try this on your own first. Tap into the store and use the off state to conditionally show the off component or the user profile component in app, and in the header to conditionally show these items or not show them. And make sure that you dispatch the login and logout actions in the appropriate places. Just one important hint, since we are merging our reducers together here, the way we access data in our store changes slightly, and we will need to adjust this for the counter as well. If we currently have a look at our application, you see the counter is not being output down there, because we failed to extract it from the store. In the counter component, our code hasn't changed, but the code here changed. All we have to do to make it work again is go to our selectors, so to use selector, and when we drill into our state to read a value from there, we now need to use these identifiers, which we assigned in this reducer map, to drill into our specific state slices. So for counter, I use counter as an identifier here. Hence in the counter component, when we want to access the counter, it's actually state.counter.counter. This might look strange, but with the first .counter, we make React Redux aware of the fact that we want to dive into this slice in the end, into the state produced by this slice's reducer. And then in that state slice, we simply have a property named counter. If that would be named differently, if that would be value, then in the counter component, it would be state.counter.value. But since it isn't value but counter, I'll revert it and revert it there as well. And that's why we have state.counter.counter. And for show counter, it's state.counter.showCounter. So when you do try this on your own for the off slice, you should take this into account when you read data from the store. And with that, try it on your own. We're going to do it together in the next lecture. Were you successful? Let's do it together. And for this, let's maybe start in the app component and render the off component if we're not authenticated, and render user profile if we are authenticated. So for this, I'll also import user profile from ./components user profile. And then here, we need to tap into our store and read a value from there. And we do that with use selector. So I'll import use selector from React Redux. And in the app component function, we therefore call use selector, pass a function to it, a function which will always receive state as an argument. that's passed in by Redux, or by React Redux to be precise. And then here I want to return state.auth, because I picked auth as an identifier here. And then in my auth slice, I have this isAuthenticated property. So it's state.auth.isAuthenticated. And that gives me the isAuth value. Of course, this constant can be named however you want. And we can use this to check if we're not, hence the exclamation mark, if we're not authenticated, then I want to show the auth component. Else, if isAuth is truthy, I want to render user profile. And if everything works, if we save, we should still see that auth form. Now we also got some conditional content to render here in the header, and therefore we can go into the header.js file and do the same thing here. We import useSelector from React Redux, and then here we create our isAuth property, our constant I mean, call useSelector, and use the same selection logic for diving into state.auth.isAuthenticated. And now we can use isAuth to conditionally render or not render those list items. And since in this case, actually the entire navigation is only relevant if we are authenticated, we can also just render the entire nav item conditionally. If isAuth is truthy, then I want to render this nav, like this. If we now save that and reload, we don't see anything here because initially we are not authenticated. Now I want to dispatch the login action if the login button is clicked. I actually won't even bother to read the user input. I will not validate it. You can do all of that, but that's not related to Redux. So I will just care about the form submission with that login button. Hence here in the auth component, we want to add an onSubmit listener on the form here, and then add a new function in the auth component, the submit or the login handler, where we get the default event, which we still should use to prevent the default, to make sure React doesn't send a HTTP request, or the browser sends a HTTP request to be precise. You learned about that in the forms section. And then with that wired up, in that login handler, after preventing the default, I want to dispatch that login action. Now for this, we want to use the auth actions, which we're exporting, and use dispatch. So in the auth.js file, we import useDispatch from React Redux. And in addition, I also want to import from, going up one level, store index. And from there, I want to import the auth actions. And then here in the auth component, we execute useDispatch to get access to that dispatch function. And in the login handler, we then use the dispatch function to dispatch auth actions.login. We execute login because you learned that this is an action creator returning the actual action object which should be dispatched. If we do that and save everything, if we reload and click on login, we switch to the login state, as we can tell by the changes on the UI. So that works. Last but not least, let's wire up the logout button here. And for this, in the header where we got the logout button, I'll add an onClick listener on that button, and then add a function here to the header component, the logout handler, where I want to dispatch my action. So again, just as before, for this we import useDispatch, and we import our auth actions from store index. We then call use dispatch in the component function to get access to that dispatch function. And in the login handler, we then we call dispatch, and to it we pass auth actions.logout, executed as a method again, because that then creates that logout action object. Now we need to wire up the logout handler to onClick, and we should be good to go. If I now click on logout, I'm logged out. If I click on login, I'm logged back in. So that is working, and that is how we can work with multiple totally different pieces of data in one and the same application. And that is something you will need in almost any React application you're going to build. You will always just have one Redux store, but then typically multiple different state slices, which manage totally different data. And as you see, it's super easy to create and manage multiple slices when using Redux Toolkit. Now, to come to an end in this module, where we learned a lot of important things, I want to split up this index.js file in the store folder. It's actually a quite small file, not too much code in it. But of course, in your typical React application, where you have multiple state slices, this can become a very long file. So therefore, it might be worth splitting it up into smaller pieces. And when using Redux Toolkit, it could make sense to put every slice into its own file. So we could add a new file in the store folder, let's say the counter slice.js file, or just counter.js. The file name is up to you. And then we want to create and manage the counter specific state and slice in there. So we would grab the initial counter state and the entire counter slice, cut that, and add it in the counter.js file. Now to use create slice, we of course now need to import that here. So we import create slice from @Redux.js toolkit. And we still also need to use counter slice in a different file thereafter. So we should export it. For example, as a default export, we can export counter slice. Now we can do the same for auth. So I'll add a auth.js file and take my initial auth state and the auth slice, cut that from the index.js file and move it into auth.js, and then also import create slice here from @Redux toolkit. And then also here, export this default auth slice. Now in index.js, we want to merge all those slices together. Therefore, we can remove create slice in there. We don't need that import anymore because we're not creating any slices in this file anymore. Instead, we focus on creating that main store and merging all the slice reducers together. Hence, we can now import the counter slice from /counter. Or, since we only really need the reducer in here, we actually go to the counter and we just export the reducer. So we don't export the entire slice, but just its reducer part. By doing that in index.js, we could import the counter reducer here, since that is what we're exporting as a default, and then just assign that as a reducer to counter, the counter reducer. And do the same for auth.js. Just export the reducer here, and in index.js, then therefore import the auth reducer from /auth. And assign this as a value for the auth key in that reducer map. Now regarding the actions, I want to export those from the files into which they belong. So the counter actions should be exported here in the counter.js file, still by accessing .actions and exporting that as a named export. And the same for auth. I'll grab that export in index.js and move that into auth.js. Now with that, if we save this, we'll need to fix a couple of imports. In counter.js, for example, where I try to import counter actions from the index file, we now need to import them from the counter file in the store folder. In auth.js, we need to import auth actions from the auth file in the store folder. In header, we need to import auth actions from the auth file as well. And in user profile, we're not using anything of that. But if we now save that, if we reload, it works just as before. All the state works as before. But now we're splitting this up, and in bigger applications, that can ensure that our code stays maintainable and is easier to manage. Because now we have a lean index.js file, and then pretty lean files for our different state slices, which are then focused on one specific type of state. Not required here, but definitely helpful in bigger applications, and even here, it certainly doesn't hurt. Now that is it for this course section. Was again another long section, but it was about a super important topic, Redux. And you did learn initially how you can set up Redux without React, and then how you can set it up without Redux Toolkit. Now, Redux Toolkit is amazing, and my strong recommendation is to use it because, as you saw throughout this course section, it's much easier to manage your state and your reducers and your actions when using Toolkit instead of having to set up everything on your own. Still, it's important to know what happens behind the scenes, which is why I did start without Redux Toolkit, so that you really know everything about Redux which you need to know, and so that you're also able to dive into projects that might not be using Redux Toolkit, but just Redux. Now then, you learn about these core Redux concepts and this Redux flow. You learn about actions and reducers, or this one root reducer, and about the fact that Redux has this one central data store. That we can create this store with configure store when using Redux Toolkit, and that then as an argument, we pass in an object where we assign our root reducer. We either point at just one reducer function, or we set up such a map of reducers which are then merged together into one big reducer behind the scenes. Now we also learned how we can then use our Redux managed data. That we can use selector in our components to read data from our Redux managed state, and that we can use dispatch to get access to that dispatch function, which we use to dispatch our actions, which then ultimately leads to our Redux state being changed. We also learned that we can pass extra data to those actions because you often have actions and reducer functions, therefore, which do need extra data. We also learned how we would connect a class-based component to Redux. We're not going to use that in this course, and you might not see it too often out there, but on the other hand, there are a lot of projects which still only use class-based components, so that's definitely also something you should be aware of. And therefore now we have a very solid foundation when it comes to Redux. Redux is an amazing library. It can replace React Context, as you learned, but it's also not a must-use library. It's always up to you to decide whether for your project you want to go with React Context or if you need Redux. React Context can have certain disadvantages, as I mentioned, but they might not matter in your project. You might not see or measure any performance issues, and you might not have a super complex setup and management. Then, of course, there's nothing wrong with sticking to React Context. Because you must not forget that if you use Redux, you do add an extra third-party library. And that, of course, adds up to the overall code of your application. It makes your application bigger. So Redux is not always better. It can be a decent option, and now you know how it works and when you should maybe consider it. Now we are going to work more with it throughout the course, but this is now a solid foundation which you need as a React developer.